Okay, this is my second video for my microcontrollers class. Basically, what we've done this week is we've wrote a device driver that allows the microcontroller from the last video, the 9S12, Freescale 9S12 to be exact, to communicate with the LCD's microcontroller. And you can actually see it on the back of the LCD right there. I don't know what microcontroller it is, but basically it's attached to this LCD, and um, there's a spec sheet for it, and basically we use the spec sheet to write our drivers for this particular LCD screen, and we enable the microcontroller here, the 9S12, to communicate with this LCD to get it to output what we want it to output. And we have some stuff hard coded into our driver right now for testing purposes. The first thing is a string, and it says welcome to 319K. That's the name of the class. And then we have some numbers. On this side we have just the raw number, and then here we have it in fixed point format. And that's something I'll explain in my next video. And actually, we just print the numbers out, and that's the highest number we can print out, is 9.999. After that, you just get asterisks, and that's something we coded into our drivers. Just, I don't know, it's for our next lab, so I'll explain it next week. Anyways, so that's that, and then I'll show you a preview of our code. And basically this code is assembly code, and this is just one level above machine code, so this is very low level code. It's basically created so that humans could write machine code without having too much difficulty, because machine code would be very difficult to write since it's all just ones and zeros. Anyways, we have our subroutines here, and we got many of them. The device drivers basically split into very functional pieces. Here we have a subroutine made for waiting for delays. Basically, we need to put delays in our drivers, because when you have two microcontrollers communicating with each other, there are timing issues. So sometimes we have to slow down how fast the microcontrollers talk to each other so they don't miss something. And then we have our timer initialization subroutine. Basically, the 9S12 has a timer built into it, and we have to tell that timer to turn on, and then we also have to tell that timer to tick every microsecond. So that's what that does. And then we have the LCD open subroutine, and this opens the LCD. When the power turns on to the LCD, the microcontroller on the LCD is actually waiting for a command. And so this is the first time we send it a command. And right here, the LCD open. We have some other ones: LCD clear, LCD out char. LCD out char outputs an ASCII character to the screen. ASCII is a coding scheme that allows the microcontrollers to know how to output letters and numbers and stuff like that to the screen. You can actually Google this. Probably make more sense if you do that. Then we have another subroutine, LCD out string. Basically what it does is it outputs a string, and the first thing you saw was a string, welcome to 319K on the LCD screen. And basically it's just a collection of letters and numbers and punctuation, stuff like that. And the very first element was the W, the second was the E, and the third was the L, so that's how that works. Now we have the another subroutine. This is LCD out dec. It outputs a 16-bit number in unsigned decimal format. Basically, in 16 bits, we can represent up to 65,000, a little bit more than 65,000, but we can't tell the LCD screen to just output 65,000. We have to actually send it one character at a time. So what we have to do is send it a 6, then a 5, and then 0, and then 0 and 0, or whatever comes after that. So the way we do that is we would first divide by 10,000 and then send the quotient. Well, we'd convert the quotient to ASCII and then we'd send that, and then we'd divide by 1,000 and then convert the quotient into ASCII and then send that, and it's just a breakdown of that. This is a recursive subroutine. It's a recursive type of problem. It's sort of hard to imagine what recursion is, but you can actually Google that too. It's really cool. I find it really interesting. Then we have LCD out fixed, and that is something I'll explain in my next video. Anyways, that's the device driver, and I hope you enjoyed my video. Thank you for watching.